Welcome to another episode of Shop Happenings. Today we're going to take a tour of the shop, see what we're doing this first 4 weeks of school. We're actually finishing up our 5th week this week. It's currently Thursday. On this first bench, you see a bunch of wood. These used to be study carrels at Ithaca College. Wonderful gentleman was able to salvage this wood. He was going to use it for a project, realized that the prep work needed to make this happen for his project was way too much to make it cost effective. He donated this to our school. The reason that they got rid of them was this split is in every glue joint. And what we've been doing is we've been sawing out defects. So as you can see here, there's a dado inside the board. This is where the study carrels went together. These dados are throughout. This board happens to be a piece that we've slowly manipulated down so that we can get to something that's about 24 inches long. It's about the maximum we can handle due to the dados. And as you can see, that dado exists all over the place. And what we're doing is we're ripping out, every time we have a split, we rip this piece of wood and get rid of the glue joint. And then what we're doing after we do that is we glue them up into a panel. So as you can see here, we've got 2 panels that we glued up yesterday. These have been very durable for us so far. You can see also here on our clamping bench, there's a panel that got glued up at the end of the day yesterday. We have a whole bunch of panels here that we glued up. This is from another project that we did a few years ago. We're going to recycle that and use that in the project we're doing. And you got to be asking yourself, what are we doing all these panels for? Well, we're going to try to make a machinist chest. And as I wander through the shop, I'm going to show you some other stuff before I get back to that machinist chest. Here, this is an adaptive chair our elementary school uses. It's upside down right now. My students are currently tracing and making measurements to build another one. They need a second one of these. These are really expensive. We have enough lumber and plywood kicking around our shop that we can put one of these together in probably a week and a half. At least that's our goal. We're going to make some subtle changes to this so that it's not completely adjustable, because some of the things that are made here don't need to be adjustable. So we're going to kind of augment the design and hopefully make it a little easier for us to make and for the elementary to use. As I wander over here, here's more of our parts for our machinist chest. As you can see, we're using the routing sheets that we've used in the past. They've been very handy for us. They're going to continue to be handy for us. There's lots of parts to these. This happens to be, according to our sheet here, a bottom drawer front and back. So this is going to be a 3-inch piece. It's 21.5 inches long. You can see right here there's a biscuit joint that was there. That's from that study carrel. That's going to be a neat little effect when this gets put together. Hopefully that doesn't screw us up. But this will be a front or a back. Right now it's sitting on our bench here waiting to go through our drum sander. Let's take a detour, go into our power portal, we call it. This is where the go-karts are. Every go-kart in here is having something done to it. I'm not going to remember everything we're doing because, well, I don't have to. On the board, as you can see, we've made quite a list. The board's broken up into bits and pieces to show which go-kart's which. Each go-kart has a numbered list of things that are wrong with it. And if we look on the go-kart, let's see if we can find one. Here's one. This is on our black go-kart. You can see that there's a tag taped to the go-kart with a number on it. And that number corresponds to the list on the chalkboard. So last year we had problems with our chain alignment, and that's something we're going to work on this year, is get this chain aligned correctly so that this go-kart stays together and runs well for us in the spring. The biggest change we're making, everything's got subtle changes. This is the big one. Last year I had a video that I discussed the chain alignment, how it gets tighter or looser depending on how the suspension's compressed. What we determined this year is our motor plate wasn't anchored to the frame centered, so that the hanger didn't hang down from the go-kart down to the center of the motor plate. So every time you applied downward pressure to the suspension, or the suspension released itself and moved up, it changed the angle of the motor, which in turn loosened or tightened the chain. And we determined that by just putting a jack under the back end and picking it up, putting it down, picking it up, putting it down. We were able to see that that happened. That was a pretty cool thing to see. I wish we'd videotaped that. But we just got this out of here a couple days ago. Students are still trying to work getting all their tools picked back up. We're going to organize this and make it right again. But this is coming along nicely, and that's in our welding area. So that's our big change for that go-kart. The go-kart that sat on the table here made its way over to our welding area, which is pretty exciting. We're going to head over there now. On our way, we're going to stop at one of our K3s. This is a vice project we're doing, or not a vice project. This is a depth gauge project that we do. We've been doing this for a number of years now. It's a really great project. I'm going to show you a set of prints. And this is a set of prints on our Logan metal lathe here. There's our depth gauge. So as you can see, it's comprised of an angled block. It's a non-incremental depth gauge. This is a press fit into the base. You have to make a little screw. None of the parts are out here because all my students pick their stuff up at the end of the day, so all their parts are locked away in their lockers so that they can find them tomorrow or today. We're going to head over, like I said, to that welding area. You can see it right straight ahead of us here. This is our newest go-kart. We've been working on this for a number of years now. What we did is last year I had a student make up 2 of these. What this is an infinitely adjustable shock adjuster. Right now it's missing its bushing up here, so oops, it's missing its bushing right here. The way this works is this will sit vertical in the go-kart, and the screw on top is threaded through that aluminum block where my thumb is, and we can infinitely adjust that shock vertically in the go-kart to adjust our ride height. That's going to help us a lot as we go forward. But what we've got here is, you can see there's a T underneath the go-kart. It's right here. That T allows us to square the frame and the tires to the go-kart, and then turn. That allows us to place our motor bracket, which is here with our axle. You can see our rotor here. There's our sprocket hub, which is right there. So this is going to allow us to square all this up so that we can figure out where that shock mount goes, which is right here. And that shock mount is going to hold this with 2 bolts. We're going to put a bushing through that so we can strengthen up the thickness of that steel, and we're going to be able to bolt this up so that if we need to ever work on this piece, we can just unbolt it, work on it, and then bolt it back on. So that's our go-kart that we're working on here. At the end of the school year last year, we mocked up, but we didn't finish. This year, we've already, in the first 4 weeks of school, my students have fixed every bushing that's in all of these connectors. So there's an aluminum bushing inside each one of these hinges. So there's 3 there, oops, there's 3 there, 3 there, 3 there, 3 here. There's just bushings everywhere. Those are out of aluminum. We're going to put a little grease on them. The reason we did that is we got in a hurry last year, made our hinges out of material that didn't match any bolt size, so we had to bush them out. My students have already finished up the bushings, got everything to work. It doesn't bind. It works wonderfully. We've already mounted our rack and pinion here. We're now trying to figure out how our gas and brake pedals are going to go, how our steering column is going to get mounted. Our seat's in from last year, so that's exciting. So we're making really good progress there. The motor plate I was telling you about earlier on our one go-kart, this is the motor plate. And I don't know why we didn't figure this out earlier, but as you can see, here's our mount for the motor. And that should be centered in here. It should be over here. So what my students have done is we've determined that if we build another one of these and put it here, so you see they've already welded this on and drilled this out, they're going to mount another one of these here that's going to go up to our bracket, so it'll keep this from twisting. What was happening as the back end of this back here, every time I went up and down, this motor plate would pivot this way. And as it pivoted that way, it changed the relationship between the motor and the sprocket in the back, and it actually loosened or tightened the chain. So what they've done is we've determined that this needs a second hanger. So they've already pulled this off the go-kart. They're welding it all up to get this done. They've got another tab. This tab right here is going to get welded to the go-kart itself. So that go-kart has to make its way over here to our welding area so that we can weld that on. And hopefully at the end of this, this will no longer have chain issues. We'll be able to make this go without chain issues, and hopefully we can get rid of our chain guide back here. That's kind of a goal we have. We don't know if that's going to happen, but we do know that this is going to stop pivoting in this direction and hopefully make that better for us. As I walk through the shop, I do want to walk over here and show you a mock-up of what this machinist chest that we're making is going to look like. So right here, we made these machinist chests. So this one was done years and years ago. It was the first machinist chest we had. We made this by hand from, actually this is basswood. It's held up really well for us. We used that design to design this one, and this is a mock-up. This was one we threw together in 2011 after our flood, and this was our original one that kind of worked out all its details. So we kept it here. We've been using it since. It still works. It's just not pretty. So this is all made out of hemlock. It functions, but in the new ones, all the spacing is going to be corrected. Like I said, this was a kind of a prototype throw together. So the new one we're going to make is out of oak from those Study Carrol parts, and that's what that machinist chest is going to look like. If I wander back over here, we'll see more parts for our machinist chest. So this is one of our drawer front and back pieces. And as you can see, we've put this rabbet on the end. And the easiest way we found to do that without chipping stuff, and there's a little bit of a chip there just because of the grain pattern, we've had very good luck. You notice this end is just solid as all get out. What we've done is we've taken our overhead router here, we've made a jig, and what happens is this board goes in the jig, these get clamped down, then we take this jig, it runs into our router here, and it can't go any further than the stop that we've set up on the bottom. So when it's clamped down, this will just run through, it cuts our rabbet for us, and on the bottom of this, you'll see that there's a board across the bottom here. This board is anchored on so that it rests against this pin, which prevents this jig from going in too far. And that prevents that board, or that prevents that rabbet from being cut incorrectly. What's really neat is the reason we made a jig this way is it doesn't matter. This happens to be a 2-inch wide drawer. So from here to here is 2 inches. We can put a 3-inch in here. We also have cut all of our little drawer fronts and backs. So over here, this is a little drawer front and back. This piece will be able to be put on there as well. And this is only 1.25 inches. That rabbet can be cut on this as well without changing the jig at all. The reason we made it that way is because of that, so that all of our rabbets and all of our pieces will be perfect, and it doesn't matter how wide this is. And this jig is configured so that it can be much wider. We could always put another clamp over here if we had a bigger board. We don't need that for this project. But this jig is really handy for us, something we designed, and it's working super well. And I love seeing students do stuff like this because it makes it so our products here and our processes become more streamlined. That's about all we got going on right now. There's more projects in the works. Please keep an eye out on the channel for more information and what we're doing. Thank you for watching, and I hope you stick around for more.